So we are going to do, everybody that ever takes calculus remembers two types of word problems. And this is the first of them. Anybody who's ever taken it, if you say, do you remember related rates? And they usually go, oh yeah, related rates. Okay, so there's two types of word problems, and we're going to be doing these related rate problems. So, since there are a bunch of words, I've sent out, if you look in notes, I have these word problems, so as opposed to watching me handwrite, so anytime we do word problems, I have to have stuff written up here. All right, so first thing you do with word problems, you read the problem. And it says, at a given instant, the legs of a right triangle are 5 and 12 centimeters long. If the short leg is increasing at a rate of 1 centimeter per second and the long leg is decreasing at a rate of 2 centimeters per second, how fast is the hypotenuse changing? All right, so here's what you do for word problems. In every related rate problem, the reason it's called related rates is you usually have things that you have multiple rates going on and somehow they're related. I'm stretching, but I'm going to call that related rates. So what do we do? Step 1, draw a picture. What picture do you think I'm going to draw?
Triangle.
What kind of triangle?
Right triangle.
Good. So everybody draw a right triangle. Okay. So I draw my right triangle. Now, one thing about pictures. Pictures are awesome. They're completely worthless unless you label them. Okay? So when you draw your triangle, you need to label them. Now, right now, whenever you draw a picture, when you label them, I want you to use letters. Next class period, we'll talk about when you can actually plug in numbers. But for today, anytime you draw a picture, pictures are great, but they're worthless unless you label the sides. And so I'm going to label my sides A, B, and C. Right? Now, one of the biggest problems with biggest issues people have with word problems is organizing your thoughts. Normally, like if you get a really long word problem, you get a whole bunch of numbers. What do you do with them? Well, I'm going to give you an option. I'm going to give you some place to put the numbers. What we're going to do is we're going to make a chart. And so you look at your picture, like we drew a picture, we label the sides. We're going to make a chart. Every letter that you use in the picture, we're going to put in our chart. So I've got an A, I've got a B, and I've got a C. Right? And just because it's calculus class or your math teacher's crazy, if you've got an A, we're going to put a dA dt. If you've got a B, we're going to put a dB dt. And if you've got a C, we're going to put a dC dt. Okay, now, you might be looking at, why are we've done derivatives, we've done that dy dx thing. Why is it d something dt? Well, because it's a rate, it's a change in something over a change in time. So you can think of this distance that a changes over the distance that time changes, like our change in distance over change in time. So you can think of these guys are little rates. This dA dt actually represents the rate that A is changing. This dB dt represents the rate that B is changing, and dC dt represents the rate that C is changing. All right, so we haven't done a whole lot yet, have we? All we've done is we set a triangle, so we drew a triangle, we labeled it, and I put some letters down, and because your math teacher's crazy, we decided to put d something dt's next to it. Now let's read the problem and fill out the chart. So it says, at a given instant, the legs of a right triangle are 5 and 12. Well, guess where the 5 and 12 are going to go? A and B. So we're going to put 5, we're going to put 12, and since the AP exam seems to be really picky about units, I'm going to be kind of picky about units here. If the short leg is increasing at a rate of 1 centimeter per second, where's the 1 going to go? dA dt. Okay? Because that's the rate that this is changing, isn't it? Is it positive or negative? Positive. Why? Because it's getting bigger, right? It's negative, it's getting smaller, right? So next up, it says, and the long leg is decreasing at a rate of 2 centimeters per second. So where's that going to go? dB dt, so that's going to give us 2 centimeters per second. Is it positive or negative?
Negative.
It's negative. How fast is the hypotenuse changing? What are we looking for?
dCdt.
Looking for dC dt, so I'm going to put a question mark. Look at that chart. It organized all our thoughts, didn't it? We have all these numbers. Now we put them. Oh, we're missing something. Huh. I got to figure out what C is, right? Well, it's a right triangle, so you can just use a squared plus b squared equals c squared, right? But we already know that. What's this number going to be? 13, right? And in case you don't know, math teachers love Pythagorean triples. Those are nice numbers that work in Pythagorean theorem. So the most common one is 3, 4, 5. Then it's 5, 12, 13. Then it's 7, 24, 25. And then it's 8, 15, 17. These are the ones that just show up every standardized test. I'll pretty much guarantee when you take the PSAT, or SAT, ACT, I'll guarantee at least 2 of these things show up every test. Now, do you really need to know them? No, I mean, it's not that hard, right? But it makes life go a little bit faster. All right, yay, I filled out my chart. But really, I haven't done any calculus yet, have I? All right, so, I need an equation that relates A, B, and C together.
That's right.
A squared plus B squared equals C squared, right? We need an equation that relates whatever letters you have in your picture. You need an equation that relates those. And oh, look, Pythagorean theorem works. And so now we're going to take the derivative. Now, we're going to make sure we know how to take the derivative here. Do you remember in implicit differentiation, when anytime you took the derivative of y, you had to put a dy dx?
Yep.
Because the y was special, right? That was because that was a y was a function of x, and that's why it was special. Well, in related rate problems, every letter is special, right? Every letter is a function of t. So anytime you take the derivative of A, there's a dA dt. If you take the derivative of B, there's a dB dt. If you take the derivative of C, there's a dC dt. So what we're going to do is take the derivative, just sort of, it's like implicit differentiation, just every letter is special. So when I take the derivative, that's going to give me 2a dA dt plus 2b dB dt equals 2c dC dt. Well, first I'm going to divide everything by 2, right? And yeah, being the teacher, you have some privileges. You can just erase the 2's. Oh, look, I've got something that relates every variable I've got, don't I? So guess what I need to do to figure out what dC dt is?
Get dCdt on its own.
Well, how to just plug all the numbers in, right? Let's see, A is 5, so that's 5 times 1, plus 12 times negative 2 equals 13 times dC dt. So 5, so that's going to be 5 minus 24 is equal to 13 dC dt. So negative 19 is equal to 13 dC dt. And so dC dt is equal to negative 19 over 13. Hopefully my math is a little better than it was second period. And so we just found out this is negative 19 over 13. The units are going to be centimeters per second. And it says, increasing, decreasing. How fast is the hypotenuse changing? So how fast is the hypotenuse changing?
Negative.
1913. Is it getting bigger or smaller?
Smaller.
How do I know it's getting smaller? Because of negative rate. Now, here's the good news. Every related rate problem works like this. Okay? You draw a picture, right? You label it. And today, every time you label it, you use letters, right? Next class period, we'll talk about sometimes you don't have to use letters, you can use numbers. But right now, we don't know that. The safe thing right now is always use letters. With whatever letters you use in your picture, make a chart. And just because it's calculus and or your math teacher's crazy, make sure you put dA dTs, put all the d something dTs, then fill in the blanks. Yes?
Instead of doing the dA dTs, can we just put A prime?
Yeah. And that's honestly what I did. The reason I do this is there's some, because honestly, when I was in high school, I did the A prime, B prime, C prime. I do the something DTs because on the AP exam, they accept both. They're both are acceptable. But in recent years, they've been using the notation D something DT more than prime as far as they're part of their question. And since they phrase it that way in the question, I at least want to show that. So that's the way I'm going to present stuff in class. If you want to write it A prime, B prime, C prime, knock yourself out. But for me, because I'm presenting it, I'm going to try to present it in the way that you're going to see it on the AP exam. Does that part make sense? Okay. All right. So that's the good news. Here's the bad news. They're not always going to be right triangles, which means you have to think a bit more. Okay? Now, since this is our first day dealing with related rate problems, right, we're going to deal with right triangles because I think that's the easiest to teach the idea. Right? And then we're going to start doing some tricky stuff, but that's next class period. All right, question 2, we're going to come back to. All right, we're going to look at question 3. Actually, you're going to do it, but I'm going to read it and emphasize certain things. It says, 25-foot ladder leans against a high wall. If the foot of the ladder is pulled away from the base of the wall at a rate of 6 feet per second, how fast is the top moving when the foot is 8 feet from the base of the wall? All right, your turn. Draw a picture. Kind of the same picture, isn't it? All right. Okay. You ready to talk? All right, so you already drawing our picture? Okay, are we okay that this is still a right triangle? Because you got your ladder against the wall, right? Which makes a right angle here, okay? Now, we don't put any numbers on our picture, right? You don't get to put numbers on your picture until the next class period. But so today we're putting letters, right? So we put letters in our picture, and I label them A, B, C, and then I have DA, DT, DB, DT, DC, DT. So now, let's read the question and fill in numbers in our chart, not on the picture. It says a 24-foot ladder leans against the high wall. What's 24?
C.
C. Okay. If the foot of the ladder is pulled away from the base of the wall at a rate of 6 feet per second, what's that? Where's the 6 go on my picture?
B prime.
DB, DT. Is everybody okay with that?
Yeah.
Because this is the ladder, right? If it's being pulled away, this length is getting bigger. And so that's 6. Is it positive or negative?
Getting the whole way.
Is this line getting bigger or smaller?
Positive.
This line's getting bigger, so it's positive. So that's going to give us feet per second. Okay? How fast is the top moving when the foot is 8 feet from the base? Where's the 8 go?
B.
Oh, shoot. Dang it. I should have done question 4. The numbers are nicer in question 4. I did question 4 second period. All right, but we're going to have to deal with some ugly numbers. Sorry. Yay. What are we looking for?
Top moving A prime.
How fast is the top moving when A prime? We're looking for A prime, all right? Do apologize, the numbers are going to be a lot uglier. This was a nice 3, 4, 5 triangle, and I forgot about that. All right. Oh, we're missing more stuff, aren't we?
Yes.
I mean, we can figure out what A is. I'm not super thrilled about figuring out what A is. What's that, 470? I'm going to
Yeah.
Well, no, 512 is 256 times 2, isn't it?
Yeah.
And that's 16 square roots of 2. Powers of 2 are easy.
I'll take your word for it.
Oh, you all know powers of 2. I'll guarantee everybody in here knows.
It's easier to keep it as a square root.
Ah, It works out okay. All right, okay, well, wait a minute, we're missing something. We're missing dc/dt. They didn't tell us. Or did they?
0.
Why?
Because the top of it isn't moving. It's a ladder. It doesn't change size.
It's a ladder. Does the ladder length? Does the ladder change in length?
No.
Everybody okay? A ladder? Or is everybody okay? A ladder is not getting bigger or smaller. So what's its rate of change? 0. Okay.
I don't get how the mechanics of this problem work. If I have a wall like this and a ladder like this, and the ladder's length stays constant, I can't.
No, but it's moving.
So it's like pulling away from the wall?
Yes. That's what it says. Pulling away from the wall. Look. Look. You still have a right triangle.
It's like falling down, sliding. So in that case, A would be decreasing.
Well, hopefully.
It should be.
Okay. All right. Well, guess what we filled out our chart. Yay. I need an equation that relates A, B, and C. Guess what it's going to be? Pythagorean theorem. So let's see, we still have our a squared plus b squared is equal to c squared. We're going to take the derivative, so that gives us 2a dA dt plus 2b b dt is equal to 2c c dt. And again, I get to use the teacher privilege and just erase those 2's. So anytime you can divide everything by number, you want to, right? Particularly when you're doing computation. And so now we plug stuff in. A is 16 square root of 2. I don't know dA dt. See, b is 8. And that's going to give me times 6. And then that's 24, but that's 0, so that doesn't matter. And let's see, that gives me 48 is equal to 0. I get 16 square root of 2 times dA dt. So dA dt is equal to negative 48 over 16 square roots of 2, which is negative 3 over square roots of 2. That didn't turn out as ugly as it could. So that gives me negative 3 over square roots of 2. We need to put our units in. This is in feet per second. We're going to do feet per second. So the negative rate tells us what?
That's decreasing.
It's decreasing. This line's getting smaller, which is what it should happen, right? Because this is going down. So everybody okay with this? Do you see how this worked the same way as the other one, didn't it? Right? We described a picture, we drew the picture, yay, right? So I draw the picture, label it, make my little chart, read the question again, fill in your chart, put numbers in the chart, all right? That's the big thing. On Wednesday, I'll talk about why you want to put numbers in the chart as opposed to putting them in the picture, right? But today, we're just putting numbers in the chart. All right, next up. We're going to look at number 5. It says one ship leaves port due north at 10 knots. 3 hours later, another ship leaves the same port and steams due west at 30 knots. How fast is the distance between them increasing when the first ship has been out for 5 hours? So this is like a modified version of what we just did. They're trying to make it harder, but it doesn't really work out. So I want everybody to draw a picture. So, see, one ship leaves a port and goes north. That was easy. 3 hours later, another ship leaves the same port and goes west. Everybody okay with that picture? And how fast is the distance between them changing? So we're looking for that distance. So I guess I need some letters. So here's A, here's B, and here's C. And I'll put A, B, and C. And then dA, dt, dB, dt, dC, dt. Oh, so knots, think of that, it's nautical, it's almost like miles per hour. It's not quite. So when you see that, think miles per hour. Okay? There is a conversion, and I don't know exactly what it is, but it's close enough, and that's what we're going to do. So, all right, what do we know? Where's the 10 go? Based on my picture.
dB.
dB dt, it's the rate that that line's changing, isn't it? Okay, so there's 10. Okay. Is it positive or negative? Positive, right? It's getting bigger, right? dB, you said dB dt, why did I put it there? Thank you. I agreed with you, because you're right. I didn't put it in the right place, okay? Okay, where's the 30 go?
dA.
30 goes the ADT. Is it positive or negative?
Positive.
Everybody certain of that?
Is it?
It's
I think
negative.
it's going back.
It's going to the west and on a coordinate plane it's negative.
That's why the discussion I wanted. Is this line getting bigger or smaller?
It's getting bigger.
Bigger.
This rate talks about if this line's getting bigger or smaller. It has nothing to do with the direction.
I just wanted to say something.
No, that was the discussion I wanted. The whole reason I did this problem is so, because the other pictures I've drawn didn't really emphasize the fact that it has to do with, is the line getting bigger or not, smaller? So, yes. If you weren't going to say it, I was about to. So. All right, so that's positive, not. All right. What are we looking for?
DC, DT.
We're looking for dCdt. A little question mark. All right. And so this is like, if like the first couple of problems I call those level 1 Pythagorean problems, this is level 2. You got to do a little work, right? Because it's not obvious exactly what these are. You got to think a little bit. All right, not much, but a little bit. So we need to find the distance. We got to figure out, how. What do we know? It says how fast is the distance between them if the first ship has been out for 5 hours. So our first ship has been 5 hours. How fast does it go? 10 miles an hour. So how far is it?
50 miles.
50. Everybody okay with that? Ship A. How long has the ship been going north? 2 hours. Okay. 3 hours later, he's been in the water 2 hours. He's going 30 miles an hour, and so that's 60. Got to figure out the c, don't I? Yay! It's Pythagorean theorem. So let's do 60 squared plus 50 squared equals c squared. So I mean, you could work this out. I like dealing with smaller numbers. So in my head. Like, you might be thinking, okay, that's 50 and that's 60. And then you got to figure out what C is, right? But what you could do, 5, 6, and whatever you get, multiply it times 10, right? So, no, because in a triangle, we're not doing area. These are all links. So if this is 5 and this is 6, so we can use Pythagorean theorem. Okay, so that's 36 plus 25 is equal to c squared. 61 is equal to c squared. So this whole thing is square root of 61, right? But this triangle isn't the triangle I want, right? The triangle I want is 50, 60. So that means multiply everything by 10. And so that's going to give me 60, 50, and then 10 square root of 61. And yay! Now this looks exactly like the other two problems we've done. I mean, the numbers aren't as nice, but numbers aren't always nice. So if I have a squared plus b squared is equal to c squared, then that's 2a dA dt plus 2b dB dt equals 2c dc dt. Divide everything by 2. So the 2's go away. I'm just plugging what we know. Got our lovely little chart. Let's see, A is 60. That's going to give me 60 times 30 plus 50 times 10 is equal to 10 square root of 61 times dc dt. You know, anytime I have an equation where I can divide everything, anytime I have an equation where I can make things smaller, see I can divide everything by 10? Just anytime I can, I want to make numbers smaller. It just makes my life easier. So if I divide everything by 10, then this becomes, 6 times 30, 5 times 10, and then square root of 61.
Yeah, 5 times 1.
And that times that?
Yeah, so wouldn't it be 5 times 1?
Wait, I only get to divide by 10 once. Think of that 50 times 10 is 500. If you divide that by 10, you get 50. So let's see, that's 180 plus 50 is equal to square root of 61 times dc dt. So that's going to give me 230 over the square root of 61 is equal to dc dt. Does this make sense?
Yes.
I want you very comfortable with the idea of how to do a related rate problem. Right? You draw a picture, you label it, you make a chart, plug stuff in the chart, take a derivative that's going to actually create the d something dt's, plug stuff in and figure it out. That's how every single related rate problem works. Okay? So let's look back at question 2. All right. As one side of a right triangle is increasing at 2 inches per second, while the other side is decreasing in such a way that the hypotenuse remains constant at 10 inches. When the length of the first side is 6 inches, is the area increasing or decreasing? And whoa. This almost looks like the questions we did, doesn't it?
Almost.
Right? It looks close. Like if I look at this whole thing and I just ignore this little last bit, then I know what to do, don't I? So let's ignore that last bit. I don't like dealing with it. We're going to ignore the last bit. It says one side of a right triangle is increasing at 2 inches per second while the other side is decreasing in such a way. Can we interpret that information? Because that looks just like the other problems we did. It says, all right, well, okay, I'm going to draw a triangle. Here's A, here's B, here's C. I have A, B, C, dA, dt, dB, dt, dC, dt. Huh. All right, if that's my picture, because this part I don't like. I don't like this, but that's I like that picture, so that's what I'm going to start with. What do we know? Where's the 2 going to go?
A prime.
Okay. Is it positive or negative?
Positive.
Okay. While the other side is decreasing. Okay, wait. Hypotenuse. Where's the 10 go?
C.
Okay, where's the 6 go?
B. No, A.
A, the first side. Okay. We okay with that?
Yes.
What else do we know?
C prime is 0.
C prime is 0. How do I know that?
But it's remaining constant.
Because it's a constant. Okay, so that's 0. Um,
B is
And what's B gonna be? 8?
6.
64.
8.
Do y'all see this is a 3, 4, 5 triangle they just doubled?
Yeah. 6, 8, 10. That's what I said. But I'm not saying.
Oh. I thought I heard 6, but.
I'm right. I said 6.
Yeah. Is everybody okay? That's an 8? All right. This looks just like the other problems we did, right? And if this is just like the other problems we did, what should they ask?
I should ask DBDT.
What's this, right? They should say, what's dBdt? Did they ask what dBdt is? No, they asked some random stuff about the area. How am I supposed to do that? I don't know. But since we're set up, would it be easy to figure out what dBdt is? So we're just going to find out what dBdt is, all right? Because that's what we know how to do, right? So at this point, I'm really sick of this. I've got A, dA, dt, plus B, dB, dt, equals C, C, dt, and let's see, there's a 6, there's a 2, there's an 8. I don't know that, okay. There's a 10, and there's a 0. So I get dB dt is equal to negative 12 over 8.
Yes.
I get negative 3 over 2. So go ahead and say that in just for a second. Yay! I solved a question they didn't ask. Because that's what I know how to do, right? I'm good at solving questions nobody asked. That's what they all this other information says, oh, I could figure this part out. I guess we should probably look at the question they asked. So what did they ask about?
The area, it's increasing or decreasing.
They asked about the area of the triangle.
You have to plug in the.
So what could I find? What's the area of this triangle?
1/2 A times B.
1 times A times. Everybody okay? The area of this triangle because it's the right triangle. The area of this triangle is 1/2 A times B. Everybody okay with that part? Now, wait, they don't want to know the area. What do they want?
The rate. So you have to find the
That
rate.
they want the rate of this. So that means I need to take the derivative at both sides. Right?
Yes.
Because anytime you want a rate, that means you're taking derivative. So the derivative of A is going to be dA dt, right? And to take the derivative of this, what do I need to do? Product rule. Yay, right? I'm going to keep the 1/2 on this. Just keep it as decoration over here. So the derivative of A is dA dt, copy B, plus derivative of that is dB dt, copy A. Huh. Oh, do I know what dA dt is?
Yes.
Okay, so that's 1/2. What's dA dt? 2. What's B?
8.
Do I know what dB dt is?
Yes.
Glad we figured that part out, didn't we?
Yes.
And do I know what A is? Let's see, that's 16 minus 9. All that times 1/2, and so I end up with 7 over 2. So dA dt is equal to 7 over 2. So there's 2 things we're going to talk about that number. Everybody see how I got the number?
No, I can't see it.
Oh, you literally can't see because there's the stack of books. All right, sorry. Okay. Okay. I want to know the units. It's a rate, okay? And since it's a rate, we're going to divide by a unit of time. So what's the unit of time going to go in the bottom? Seconds. All right. What unit goes on top?
Inches squared.
Square inches, because it's area, isn't it? Right?
Yes.
This is the rate that area is changing, so I'm going to say square inches. So our unit is, square inches per second. Is the area increasing or decreasing?
Increase.
Increasing.
How do I know it's increasing?
Because 7 over 2 is
Because you have a positive number, right? Now, this came up in second period where someone was like, well, is it always increasing? No. It's increasing at that instant. This represents, these are the rates when this is 6 and this is 8 and this is 10. If these change, these will change, right? So if these change and these change, that means the rate that the area can change. So that's it. It all depends. They all talk about at that particular instant. So, what's interesting about this problem? This is actually can be typical of a multiple choice question.
Multiple choice.
Yeah, it kind of stinks, doesn't it? Look at all there's lots of places to go wrong, right? Not my rules. It's just what the AP exam has done in the past. Notice that they didn't ask you to find this, did they? Could we have answered the question unless we had that? Do you notice that we needed this to actually answer the question? So I have a couple of options when I teach. One is I could start here, take the derivative, and say, oh, we need to find out what dB dt is. I actually think the way you should think about these problems is if they give you information and you say, and it's like, why didn't they? It's like they didn't ask for that. They didn't ask for dB dt. Go ahead and find it because you're probably going to need it to actually answer the question that they want. And this is how they make things a little tricky. Now, today, all I did, okay, so I'm going to actually, that's going to be good.